Assalamu alaikum warahmatullahi wabarakatuh. May the peace, blessing, and mercy of God be upon you. Today we will start solving computer science OL paper 1, October, November 2023, variant 1. We will solve this exam in 3 videos. You can find link in description. Number 1, a student uses computer and several hardware devices to complete his schoolwork. The computer has central processing unit CPU. The student uses a keyboard to complete his schoolwork. Take right one box to show which type of device the keyboard is. Keyboard is an input device, so it will be number 1 or number A. B, the student uses printer to print his work. Take right one box to show which type of device the printer is. Printer is an output device. We take the paper from the printer, so it will be output device. A component in CPU sends signals to manage the fetch, decode, execute cycle. So let's remember the CPU components, the arithmetic logic unit and control unit and registers to execute the fetch, decode, execute cycle. The control unit sends the signal to control this data transaction. So this will be, the name of this component is a control unit. The CPU has clock speed of 2.4 gigahertz. Describe what is meant by 2.4 gigahertz clock speed. That's mean that the CPU execute 2.4 billion cycle per second. Okay. The CPU contains registers, including the memory data register MDR. Describe the role of the MDR in the fetch execute cycle. This MDR contains the data we fetched to execute it. So MDR used to store the data or the fetched data. Okay, identify 3 other registers contained in the CPU. As we remember, program counter, which have the instruction address. We give this address to MAR, memory address register. This memory address register take data from MDR, memory data register, which sends to CIR, current instruction register, to produce the to decode and execute the instruction. So we can say program counter EC, memory address register, MAR, and current instruction register CIR. And if you want to write the register used with arithmetic logic unit, you can say accumulator. This is extra. Okay. Number 2, a car park has a payment machine that allows a customer to pay for this parking. The cost parking is displayed as a denary number on the screen on the payment machine. The cost parking is stored in 2 8-bit binary registers. For the parking cost of $10.50, register 1 stored the denary value of 10, and the register 2 stored the denary value of 15. So give the parking cost that would display on the payment machine when the register stores register 1 0 0 0 1 0 0 0 1. This will be 1 2 4 8 16. So 16 plus 1 equals 17. And the second register 0 1 0 0 0 1 1 0 1 2 4 8 16 32 64. So it will be 64 plus 4 plus 2 equal 70. So the parking cost displayed will be 17.70. Okay. Number B, the parking cost of 14.98 is displayed on the payment machine. Give the 8-bit binary. We need to write the 8 bits number that are stored in the registers to display the parking cost. So the first one is 14. 14 will be 1 2 4 8, which is 1 1 1 0, and the rest will be 0. So the register 1 will be 0 0 0 0 1 1 1 0. And the second register, which have 89 1 2 4 8 16 32 64. So 64 subtract 64 from 89. This will be 4 3. 4 3 will be 32, and the remainder will be 2, and the rest will be zeros. So this will be 2 4 6 7. So 8 will be 0 1 1 0 0 0 1 0. The payment machine gives the customer tickets when they have paid their parking cost. Each ticket has 4-digit hexadecimal ticket number that is stored as binary. The binary number 0 1 0 1 0, then 2 4 zeros, then 0 0 1 1 and 1 1 0 1. Okay, give the hexadecimal ticket number that would be displayed on this customer ticket. Okay, let's write it 1 0 1 1 1 2 4 8, which is 13. 13 will be D. And 1 1 0 0 1 2 4 8 will be 3. And 0 0 0 0 will be 0. And 0 1 0 1, which 1 2 4 8 will be 10. 10 is A. So the hexadecimal will be A03D. Okay. Explain why data input into the payment machine needs to be converted to binary, because the machine contains logic gates that processes one or zeros and zeros values. Okay. When a customer leaving in the car park, they arrive at a barrier. The customer needs to insert this their ticket into the system at the barrier. The system reads the ticket number, then checks whether the parking cost has been paid for the car. The barrier is raised if it has been paid. The system uses microprocessors. Describe the role of microprocessor in the system and how it checks whether the parking cost has paid. The microprocessor compare with the database. The microprocessor compares the ticket number received with the stored data in the paid database, and if the value found, the microprocessor sends an activator signal to raise the barrier. Otherwise, nothing happened. And the barrier remains closed. Okay, number 3. The table contains 4 descriptions about the computer system. Complete the table by writing the correct term for each description. A collective terms for the physical components on the computer system, this will be hardware. A type of software that provides service that the user requires and allow user to perform tasks on the computer. This is an application software. The type of software that manages the main functions of the computer, including managing files and managing memory. This is the operating system. A type of software that's stored in the read-only memory. It includes the binary input, basic input-output system BIOS and bootloader. In the memory, we store the firmware. And that's it for now. Next video, we'll start with number 4. Thanks for watching. See you next video.